Hi class, today we are going to talk about binomial radical expressions, which is found in section 6-3, part 2 of your book. We will add and subtract rational expressions. Alright, specifically, and I should have written this, we're actually multiplying and dividing radical expressions. So here we go. The first one, we're going to start by multiplying. The best way to multiply radical expressions. You can use distributive property, but it can get a little bit messy. We've used the area model, the box method before, so that's what we'll do here. Alright, so I'm going to draw a box. And we have a 4 on top, and then a 2 square root of 2 here. Then we have a 5 and a 4 square root of 2 here. Okay, 5 times 4 is pretty simple. That's going to be 20. Okay, 4 times 4 is what we're actually multiplying, right? Because you have to do like terms. So 4 times 4 is 16, and we're just going to attach the square root of 2. 5 times 2 is what we'll multiply next, and that will give me 10, and then I attach the square root of 2. And then finally, for the last box, we have 4 times 2, which is 8, but then the square root of 2 times the square root of 2 is actually 2. So 8 times 2 is really 16. All right, with that being said, both diagonals then are like terms. So 10 square root of 2, let's do the whole number first. So 20 and 16 will give us 36. And our radicals, 10 square root of 2 and 16 square root of 2 will give us 26 square root of 2. And it doesn't matter which order you write them in. All right, let's do a box for the second one. So that's 3 and negative square root of 7. And this is 5 and square root of 7. So 5 times 3 is 15. This will give us 3 square root of 7. This will give us negative 5 square root of 7. And this will give me, now again, look at the coefficient. There's a 1, and this is technically negative 1. So this becomes negative 1 times the square root of 7 times square root of 7 is 7. So this gives me negative 7. So when I add these terms, 15 and negative 7 will give me 8. And then 3 square root of 7 and negative 5 square root of 7 is negative 2 square root of 7. Alright, so here we go. We're going to go ahead and create a box. This is 3 and 2 square root of 5. This is 2 and 4 square root of 5. So 3 times 2 is 6. This will give me 12 square root of 5. This is 4 square root of 5. And this is 8. 4 times 2 is 8. And the square root of 5 times square root of 5 is 5. So this is really 40. So when we're done, this will give us 46 plus 16 square root of 5. Let's keep going. All right, so conjugates, we've talked about conjugates before when we were talking about imaginary numbers. All right, so once again, conjugates basically will have the same A and B, but their sign in the middle is opposites. So it says what's the product of the expression? So we're going to go ahead and multiply. We should know the outcome. We should know that it's really just going to be a square of their outer terms, but let's prove that. So this will give us 25. This is going to be 5 square root of 7. This will give us negative 5 square root of 7. And again, looking at the coefficients, that's 1 and negative 1. So that's negative 1. And square root of 7 times square root of 7 is 7. So this is really negative 7. So 25 minus 7 is going to give us 18. And that's actually it, because those, the diagonal, will cancel because they are opposites. So 18 is our final answer. So again, I've once again tried to show you and prove to you that the it's really just a square or a difference of your squares. So of your first and last term. So your first term is 5, so it's really 25, right? Square root of 7 times the square root of 7 is really just 7, and I said it's a difference. So 25 minus 7 is your 18. And this will always be the case when you're dealing with conjugates. Okay, so I could just prove my point in the beginning, or I could just work it out. So I'm going to prove to you first that our answer is going to really be 6 squared minus the square root of 12 squared, right? Because they're conjugates, so that would mean that this is going to be 36 minus 12, which is going to give us 24. But let's do the box method to prove that that's true. So it's 6 negative square root of 12, 6 square root of 12. 6 times 6 is 36. This will give us 6 square root of 12. This will give us negative 6 square root of 12. This is going to give us negative 1, and then square root of 12 times square root of 12 is 12. Those are gone because they're opposites. This is really negative 12. And that's exactly what we said. 36 minus 12 is 24. All right. So without even doing the box method on the last one, I'll just do this second approach that I'm going to do here. Because they're conjugates, it's really 3 squared minus the square root of 8 squared, which is really 9 minus 8, which is 1. All right, so with that being said, the only reason why we were trying to deal with conjugates is because we need to rationalize the denominator. Just as we've talked about before, you cannot have non-normal type numbers in your denominator. So we never like to see imaginary numbers in the denominator. We never like to see radicals. So there are a few things that we don't like to see in the denominator, and since that's the case, we need to do certain types of manipulations to get them out of the denominator. And in this case, we're going to rationalize by multiplying by the conjugate. So here we have 3 square root of 2 over square root of 5 minus the square root of 2. So that's going to be we need to multiply by the conjugate, which is the square root of 5 plus the square root of 2. So we could do 2 separate boxes if we would like. So this is, actually the first one doesn't really need a big box like that. It's a 1 by 2. So this is 3 square root of 2. And then we have square root of 5 and square root of 2. On this one, we have square root of 5, negative square root of 2, square root of 5, square root of 2. All right, everything's been put in its place. Now, the top box is the numerator, the bottom box is the denominator, all right? So, for the first box on the numerator, 3 is the radicals. So, 3 is the whole number, so it's going to stay out. Square root of 2 and square root of 5, they're unlike terms, so we're just going to put them together. So 2 times 5 is 10, so it's going to be 3 square root of 10. And then for the next one, we have 3, and then square root of 2 times square root of 2 is 2, so 3 times 2 is really 6. So this numerator so far is 3 square root of 10 plus 6. We're going to keep going though. All right, square root of 5 and square root of 5 is 5. This is going to be square root of 10. This is going to be negative square root of 10. And this is going to be a negative, and then 2 times 2 is 4. Or excuse me, not 4, but square root of 2 times square root of 2 is 2. Okay, these are they're opposites. And what's left is 5 minus 2, which is 3. Now, the final thing that we need to recognize here is that 3, 6, and 3 are all divisible by 3. So we can divide all of those numbers by 3, and we will be left with the square root of 10 plus 2, and that's it. All right, let's look at our last problem. It says, how can you write the expression with a rationalized denominator? So the first radical, the conjugate is going to be the square root of 3 plus the square root of 5 over the square root of 3 plus the square root of 5. All right, again, that's a monomial, and the second one is a binomial. So 2 square root of 7, 2 square root of 7, and then this one is square root of 3 and square root of 5. This one is square root of 3 minus, or negative square root of 5. This one is square root of 3 and square root of 5. This will give us 2 square root of 21. This is going to give us 2 square root of 35. This one isn't very nice. All right, the next one is going to be square root of 3 times square root of 3, which is 3. This is square root of 15, negative square root of 15. and this will be really -5. The diagonals are gone. We're left with -2. So for this problem, we're going to have 2 square root of 21 plus 2 square root of 35 over 2. Once again, they all have a 2 in common, so they can all go away. So we're left with the square root of 21 plus the square root of 35. Alright, so in our last example, we need to multiply by the conjugate. So our conjugate is 3 plus the square root of 6 over 3 plus the square root of 6. Okay, so we'll do the monomial for that one and the binomial here. This will be 4x and 3 square root of 6. This will be 3 square root of 6 and 3 negative square root of 6. This is going to be 12x, and then this is 4x square root of 6. This will be 9, negative 3 square root of 6, 3 square root of 6, and then negative 6, really. Those are gone. 9 minus 6 is 3. And this is going to be over, 12x plus 4x square root of 6. Ooh, I can't fit it. Try that again. 12x plus 4x square root of 6. Alright, once again, 12, 4, and 3. Actually, that's it, because they can't be reduced by anything. However, 12x and 4x share a 2 in common, so I should factor out a 2x actually to leave us with 2x in parentheses 6x plus 2 square root of 6 over 3. And because the 2 and the 3 can't be reduced, we would leave it alone. So this would be our final answer. Alright guys, once again, if you have any questions, please be sure to check with me for tutoring.